get started. So today we're going to review math, which is a built-in Java library that you can use to do mathematical equations. You can do, exponents. You can do square roots, all different kinds of things you can use math for. You can randomly generate numbers if you like. We're also going to review switch and if statements. Can anybody tell me what the difference between an if and a switch statement is?
If statement is you know how many times you're gonna use the program, and the switches if you don't know. I think
That's close. That's more of a for loop and a while loop. The if statement, that's actually really close though. When we get to loops, that would be the correct answer. But with switch and if statements, really the main difference is a switch, you have to know exactly what the outcomes are, right? So for example, you give a user the option to type in, would you like to choose apple or orange? You know there's two options. You can use a switch statement. An if statement is great when there's conditions, like if the apple's hue or color is greater than a certain red, do this, right? If the color of the fruit is less than a certain orange, do this. So it's really good for ranges, whereas the switch statement is we kind of know what our options are. It's really good for user input. And honestly, that's the only time I use a switch statement is for user input. So let's build our first, let's start from scratch, making our Java program. So of course, the first thing we need is our class, public class review2. And then every Java program needs a main method, public static void main string args. And of course, both of these need closing brackets to go with the opening brackets, right? So we have our opening brackets and then we have our closing brackets. Everybody with me so far? All right. So let's start off with the math library. Let's say I want to write a program that, let's see, determines a number raised to another number. Both numbers are read from the console. So essentially what I want to do is read a number from the console and raise that to the power of another number that I read from the console. All right. So for example, the user types in a 5 and they want to do the square of 5. So 5 times 5 would be, the outcome. So very similar to that, except we're going to read in both those numbers from the console. So we want to read from the console. What do we need every single time?
Scanner.
Yep.
scanner.
Yep. Scanner input equals new scanner. System.in. Again, this line of code right here is important because that tells us we're reading from the console, system.in. When we learn about reading from files, we'll actually put a file right here instead of the system.in, but that's going to be later on this semester. So when we want to use the scanner, we have to import java.util.scanner. All right. So let's read that first number. So we have to create a variable to hold that number, and I'm going to do an integer just to make it simple. It's going to be a whole number. So int base, because it's the base number, equals integer.parseInt input.next line. Again, this reads the next line from the console, and then it converts it to an integer. All right. Int exponent equals integer.parseInt input.next line. So I'm reading in two numbers, the base and the exponent. And because when we move to NetBeans, we're going to have to prompt our user. I'm just going to get in the habit now of prompting the user. System.out.println. Please enter the base number. So that's going to tell the user to enter the base. System.out.println. Please enter the exponent. And again, when we move to NetBeans, this will make more sense. And I actually might just switch to NetBeans next class just so we can get used to it. Because the visualizer is good, you can see it. But as we start making more complex programs, we're going to need NetBeans' capabilities. Okay, so we read in the two numbers.
Hey, I got a question, Professor, real quick.
Go ahead.
Couldn't I use Notepad as well for Java? I mean, I just, it's just a general question. I know we're going to use NetBeans. I just wanted to know.
You can, and there's nothing wrong with using Notepad++. The only difference is with NetBeans, there's a lot of built-in features that are really helpful to a programmer.
Okay.
And you'll see those when we start diving into NetBeans.
Okay.
So we have our exponent, we have our base. Let's compute our output. So I'm going to make this another integer. Output equals, and then to use the math library, we just go math.exp. That tells us the math library, capital M, .exp. I want to use the exponent method. The first number is your base, comma, whatever you want to raise it to, the power you want to raise it to. And there we go. So now system.out.println, the output is the output of raising our base number to the power of plus our exponent is plus our output. So this might look like a very long line of code, right? What is this called when you're adding in these numbers to a string? It's called string what? Starts with a C.
Concatenation.
Yep. Yep. String concatenation. Basically, I'm adding these numbers to a string. I'm adding strings to a string, whatever it is. And what Java does is it interprets this number, converts it to a string, and just adds it in here. If you notice, I put spaces here and here. If I don't put those spaces there, it'll put this number right up on that and right up on the 2. So spaces are important in your strings as well. And so when we run this line of code, what it's going to do is the output of raising whatever our base number is, so let's say 5 to the power of 2 is, and then whatever our output is. So let's visualize this. I spelled print line wrong. Oh, so it wants a double. Or it wants these to be doubles. Let's see. And I could just do that real quickly. Maybe not. Maybe it doesn't like that. Oh, I'm using the wrong method. That's why. It's math.pow. See how many times I've done this. So it's not math.exp. That's a different method. It's math.pow. All right. So math.power. And say incompatible types. You might lose some precision. Basically, what it's saying is Math.pal outputs a double. By making this an integer, I might lose that precision, right? So let's say I put two doubles in here, 5.5 to the power of 2. You all might be better than me. I think the output is like 25.25 or something. I don't know exactly what the output is, but whatever that output is going to be 25.25, for example. If I try to put that into an integer, it's going to cut off that 0.25. So all it's saying is you might lose some precision. So instead, I just make that a double and we're good to go. All right. So again, please enter the base number. I'm telling the user, and actually I'm going to get an error. And this is an error that some of you all may have encountered over the weekend. And I just realized I'm going to have it. What is going to be my error?
No clue. I have absolutely no idea what that error is going to be.
So if you notice, I haven't put any input in. So it's going to try to read from the console, but no line was found. So let's put some input in. Let's do 5 to the power of 2. Let's visualize this. All right, we create our scanner. We say, please enter the base number, and we say our base number is going to be 5. Let's read that in. Boom, base is 5. System not out, please enter the exponent. Read that in, exponent is 2. We do math.pal, 5 to the power of 2, 25.0. And then our last line of code is going to say the output of raising 5 to the power of 2 is, it should say 25.0. Yep. There you go. So within the math library, again, there's a lot of different methods that we can use. I just want to show you all one. And as we go throughout the semester, you may have to use the math for like square roots or whatnot. But square roots are the same thing. Instead of math.pal, it's math.sqrt. Whatever the number is, and then obviously you don't need anything else. So that's how you do the square root of something. Okay. I believe so anyway. Yep. So this would be the square root of 5, which of course, I don't know the output of that, but Java will figure it out for us. Any questions about the math library?
Negative.
All right. Let's move on to if statements and switch statements. Okay. So a switch statement, let's start with if statements actually. So let's say the temperature is cold right now, right? It's freezing outside, I believe, if it hasn't warmed up since this morning. So we're going to have a program that reads in the temperature, okay? And depending on what that temperature is, it's going to have different outputs. So if the temperature is over 100 degrees, we're going to say it's hot or extremely hot. If it's over 80 degrees, in between 80 and 100 degrees, we're going to say it's hot. If it's between 40 and 80, we're going to say it's good. I know it's a big range. Anything less than 40, we're going to say burr, it's cold. All right. So now we're starting to build more responsive programs, and we can control the execution of our program based on whatever logic we insert into our programs. And so this is how many apps work, right? Many programs, many apps work. For example, you might be on a web page that when you scroll to the bottom of the page, it starts spooling again. It's loading more stuff, right? All that is an if statement. If the user reaches the end of the page, go retrieve more items, right? If we're on TikTok, for example, if the user swipes up, load the next video, I believe. If the user swipes down, load the previous video, right? On our phones, I have an iPhone. If the user swipes left, I believe, well, swipes from left to right, go to the previous screen. right? If the user clicks a certain button, do this. So now you can start thinking how prevalent these logical statements are in everything we use with technology. If statements are fundamental to programming. Same with loops, switch statements as well. And then as we go throughout this class, you'll see that object-oriented programming concepts, which are the 4 pillars of object-oriented programming, are instrumental to most modern day programming languages as well. And out of curiosity, can anybody tell me what those 4 pillars are? I'm going to just repeat them over and over throughout the entire semester. So the first pillar is abstraction, all right? The second pillar, encapsulation, then inheritance, and then finally polymorphism. So those are the 4 pillars that we are pretty much going to drill home in this class, are those 4 pillars, and that's the foundation of most modern programming languages. If you learn those 4 pillars in Java, you should be able to learn any other object-oriented programming language like Python, C++, C#,
R?
Objective-C, Swift, R. I think R is object-oriented programming. If you understand those pillars, though, then it just comes down to the syntax of the language. How do you write these things? Right? Python is a little bit different than Java. Okay. So let's do a if statement. Again, we're going to read in the temperature. And then depending on the temp read in, our program will have different output. Okay. Okay. So again, we want to read from the console. We need a scanner object, new scanner, system.in. And in my previous classes, I've said this is a scanner object, right? Without ever actually explaining what exactly an object is. In this class, we'll learn what objects are and how they work. When I say it creates an object in memory, it actually creates a physical kind of structure in the memory of our computer that has its own little unique characteristics. util.scanner, because we want to use the scanner. All right. So double temp equals double.parse double input.next line. Okay. Everybody with me so far, what I've done, right? Okay. So we have our temperature. Again, user can type in anything they want. If we have a automated system, it won't be user input, right? We'll be reading from a sensor. And we will just make a sensor call. Every 5 seconds, every 10 seconds, we're going to call our sensor and read whatever temperature is, recorded by our sensor. So as you all get more advanced, if you buy a Raspberry Pi and buy a temperature sensor to go along with it, you could create a thermostat or automated temperature sensing system for your home. It's cool little projects you can do once you learn how to program. And Raspberry Pis are in Python, I believe. All right, so we read in our temperature from the console. Then we'll say if temp is greater than 100. I have a different descriptive word I would use for that hot of a temperature, but I'll say, dang, it's hot. All right. Got family down in Mississippi, and I swear every time I walk outside, I melt. All right. Else if temp is greater than 80. Right. So this is how we do our if statements. If this is true, do this. If it's false, go to the next else if. All right. Else if this is true, then we do this. System.out.println. It's pretty hot outside. Else if temp is greater than 40, I believe. System.out.println. We're good. And then else, so this is kind of a default case. If all of those other ones are false, it's going to go down to our else statement. Else system.out.println. Brr, it's cold. Right? And there we go. So if our user types in a 79.9, what will our program say? Again, this class is more about dialogue than
We're
programming
good.
one. Yeah, it'll say we're good. If the user types in a 100, what will it say?
Dang, it's hot.
Yep. All right. Let's see. If the user types in a 40, what will it say? Actually, you know what? If the user types in a 100, it won't say dang, it's hot. Because this is strict. It must be greater than 100. It can't be equal to. If we had greater than or equal to 100, that's different. But greater than, it must be greater than 100. So it could be 100.000000001. But as long as it's greater than 100, and since these are doubles, I'm going to put 0.0 in. So because we want to include 100 into our if statement, I'm going to do greater than or equal to. Same with 80, greater than, equal to, greater than, equal to. That way, if they put in a 100, it's going to say, dang, it's hot. So let's test this. I'm putting in a 100. Forward. And you see, let me go back one. It's going to check if temp is greater than 100. This is true. Go into our if statement. Print out, dang, it's hot. And then our program ends. It doesn't even evaluate these other ones. Once it finds one that's true, it skips them entirely. That's if they are else ifs, right? Else ifs and else connect to a kind of a root if statement. So for example, you can't just have a random else if hanging out there. This is going to give you an error. It's going to say else if without if, right? So you have to have an original if statement as the first kind of starting point, and then these. Now I could just make these if statements, right? And our program will work the same, except the difference is it's going to evaluate the first one. So it's going to go down to this one, say it's true, and it's going to evaluate that one as well, which is also true, right? So it has two outputs. Well, we don't want that, right? So it's important that you understand the logic of your program. Two if statements means it's going to evaluate these both individually. They aren't connected anymore. It's not one or the other. If I make this instead, else if, now they're connected. It's going to evaluate only one. If one of these are true, it's going to skip the rest. And it does go top to bottom. Any questions about if statements? And again, as we go through this class, these are going to get a lot more complex. So I encourage you all, if there is some fuzziness to this, to go back and watch those videos, just so that you can be, on 100% footing as we go forward. We will start making more complex programs. So if this, if the user types this in, make sure you do this calculation. If not, don't worry about the calculation, things like that. So make sure that you all understand this, pretty good. All right, so switch statement. So let's give the user the option to type in the temperature in, actually, let's not do temperature because I believe your assignment does converting temperatures. So let's do something else. Let's see. Let's do a switch statement for our favorite athletes. Okay. Now we're gonna have to. I'm gonna solicit them from the crowd, so I need you all to help me in this. So
I'm too old. I'm gonna sit out.
that's all right. So first of all, we need something to switch on, right? So the user input, int option. I need that scanner again. We give the user an option, int option to choose. And we're going to read that from the console, integer.parseInt, and that'll make more sense in a second. So when we have a switch statement, and actually I want to prompt the user for their option. So system.out.println, please enter your choice. System.out.println, who should be the first athlete or famous person? It doesn't matter. One from each of you.
LeBron James.
Ah, boo.
LeBron James. All right. System.out.println. Who's the next one?
Man, the GOAT, Michael Jordan.
All right. Michael Jordan. Sorry, I messed up. I misspelled the first one. That's better. All right.
Way better.
System.out. You said what?
Way better.
Who should be the next one?
Stephen Curry.
It doesn't have to be basketball, y'all. It could be a different sport. All right, Jazir. What you got? Jazir, you there? I can't tell if he's there. All right, I need you to respond here soon or you're going to get booted. So can somebody else give me another athlete?
Lawrence Taylor.
Lawrence Taylor. Did I spell that right? I believe so.
Mm-hmm.
Yep. All right. There we go. So we have our 4 athletes: GOAT James, Michael Jordan, Stephen Curry, and Lawrence Taylor. Okay. And we're telling the user to please enter your choice. 0 for GOAT James, 1 Michael Jordan, 2 Stephen Curry, and 3 for Lawrence Taylor. There we go. So those are our 4 athletes. So again, a switch statement, we can do this in an if statement. So if option equals 0, you know, we could say system.out.println, good choice, right? You know, they made a very smart and intelligent choice. Else if option equals 1, system.out.println, Air Jordan. Else if option, and remember, so I capitalize my O here, that's going to be an error. My option is lowercase. Option equals 2. System.out.println, Splash Bro. And else if option equals 3. System.out.println, watch your head. And then else. Why should I put an else here? I could just do 0, 1, 2, and then just do an else here, right? Because the only other choice they have is Lawrence Taylor. But why did I specify option equals 3, do this, else? What should I put down here? Krishan, I need you to turn your camera back on. Why do I have else down here? For incorrect input, right? If they put in something that we're not expecting, we want to account for that. As a programmer, that's important, right? How many times have you used something, an app or program or whatever, and the son of a gun crashes on you, right? Well, typically that's a programmer error. They didn't account for whatever situation that you're putting their program through. So it's important to always think, especially for user input, how can they break my program? And how do I make sure that it responds accordingly and properly? All right. So we do system.out.println incorrect input. There we go. So now we give them 4 choices. If they don't choose one of those 4, you type in something that we're not expecting. Another scenario that could occur is, what if they put in, a letter instead of a number? All right, we're trying to convert whatever they type in into an integer. Well, if they put a letter in, obviously a letter is not an integer. So for example, what if they put a J in? Well, that's going to give us an exception. Okay. We'll learn about how to handle exceptions later on in this class. That's another case that we need to account for as the program. But again, this program should work as expected. I'm going to put in a 3. So what do I expect this to say? If I put a 3 in, go ahead, what'd you say?
Lawrence Taylor.
Well, yeah, they selected Lawrence Taylor, but what should the program say?
Watch your head.
Yep, watch your head. Of course, I spelled print line wrong. All right. So we go forward, create our scanner object. Again, we're going to explain what an object is later on in this class. We're telling the user our choices. Again, it's always important to prompt your user. You got to tell them what they're putting into your program. 0 for Goat James, Michael Jordan, Stephen Curry, and Lawrence Taylor. We read in the option and they put in a 3. It's not option 0, so it's going to go to the next else if. Option doesn't equal 1, next else if. Doesn't equal 2. Option equals 3, watch your head, and we're done. So let's just test our program. They put an 8 in. What do we expect it to say?
Incorrect input.
Incorrect input, yep. Incorrect input. And here's what I was talking about. What if I type in goat, right? What do you think will happen when I run this program? We're going to have that exception that I was talking about. All right, number format exception. And again, as we go through this class, we'll learn how to handle exceptions. We use something called a try catch. Okay, so I did this all using if statements. Instead, we can use a switch statement, and really it just makes it cleaner, especially for user input. You're not required to use a switch statement. It does make it look a little bit better though. So let's do that switch statement. So instead of doing all these if option equals this, especially when we're just doing equality, right? We're just checking to see if it equals something. All we have to do is switch
I'm not.
on whatever that integer is. All right. Then we have something called a case 0, which basically all that says is if option equals 0, do this. All right. And then we break. If we don't have this break statement, it's going to evaluate each one of these subsequent cases. So The break is important. Case 1, Air Jordan, break. Case 2, Splash Bro, break. All right.
Oh my God.
Case 3, Watch Your Head, break. And then instead of else and if and a switch statement has default. Right. And there we go. There's our switch statement. Now it just looks a lot cleaner than having all those different if statements, especially when they're really simple things. It's really good for user input. All right. If I still have GOAT down here, I'm going to get the same error, but let's put a 2 in. What do we expect it to say? Anybody?
A Splash Bro.
Yep, Splash Bro. All right, so let's test it. So we go forward, prompting the user. We read in the user input. It's 2. We switch. And you see it goes instantly to that case. So it's a little bit more efficient as well. Splash Bro, break, done. Right. A little bit more efficient than that if statement because the if statement goes, all right, let's check this one, then check this one, then check this one. Whereas a switch statement goes instantly to whatever the case is. It does it, it automatically.
Oh my God.
Did you have a revelation?
No, I keep getting the same error. I'm about to reload my page.
What's your error?
All right, it says, I think it might be a semicolon that I put, or it's missing a semicolon on Air Jordan, like on case 1.
Mhm.
Yeah, I got it. I found it. Thank you.
And these are colons right here, right? After the case.
Yeah,
these are
yeah, I
colons.
got those. Yeah, it was just the semicolons. I had missed it on the if statement, and then when I transferred over, I just never put it back there.
Gotcha. Yeah, semicolons will wreck your program if you don't keep up with them. So I put in a 0. So I expected to say good choice. Yep, good choice. Right. They chose GOAT James, so that's definitely a good choice. All right, let's put in a 10. I'm expecting it to say incorrect input. Yep, incorrect input. And again, I think next time on Monday, well, on Friday, actually, because we're doing review on Friday as well, I'm going to switch to NetBeans so that you all can see it in NetBeans, what it's going to look like and how we can start projects and things of that nature. So this would be probably the last day we use the visualizer. Now, for all these review assignments and labs, or just the assignments, you should be fine using the visualizer. But as we start doing more complex programs in this class, you will need a more robust IDE or integrated development environment like NetBeans or Eclipse or IntelliJ, which is through JetBrains. I actually like IntelliJ, but NetBeans is good too. Any questions about what we covered today?